Good evening and welcome. Tonight, since it's the first night in September, we'll be going over the night sky for this month. We'll look at the Northern Hemisphere stars and then the Southern Hemisphere stars. And then we'll look a little bit more about one of the constellations we can see at this time of the year. And then we'll learn a little bit more about outer space. So let's just dive right in and let's look at the sky in the Northern Hemisphere. So it says the summer triangle of bright stars, which we talked about last month. We have Deneb in Cygnus, which is right there. We have Vega in Lyra and Altair in Aquila. Let's see, there's Aquila, there's Altair. Is farther over to the west than it was during August, but it is still a useful guide for finding some less well-known constellations. Inside the summer triangle between Cygnus and Aquila, you will find two small constellations of Vulpecula, the fox, let's see, Vulpecula, and Sagitta, the arrow. Sagitta, let's see, there it is, Sagitta. They are close to the Cygnus Rift, a dark lane of dust that seems to split the Milky Way in two. Let's learn a bit about Aquila. In Greek myths, the eagle Aquila carried thunderbolts for the mighty god Zeus. Aquila's brightest star is Altair, while Eta is a Cepheid-type variable star. Cepheid variable stars pulsate over a period of days, varying their size, temperature, and brightness. Eta's brightness varies over roughly 7 days from magnitude 3.6 to 4.5. Here you can see Vulpecula and Sagitta. Vulpecula, the fox, is one of the constellations devised in the 17th century. Within Vulpecula lies the Dumbbell Nebula, or M27. Though visible through binoculars, only larger telescopes reveal its distinctive shape. Sagitta is much older, dating back to ancient Greece. Unusually, its brightest star is not Alpha but Gamma at the arrow's head, which has a magnitude of 3.5. This one definitely looks like an arrow, doesn't it? Let's see, did you know the Dumbbell Nebula in Vulpecula was the first planetary nebula to be discovered by Charles Messier in 1764. In 1967, astronomers from Cambridge, England, discovered the first ever pulsar, named that, in the constellation Vulpecula. Pulsars are rotating neutron stars. Very interesting. Let's flip over this book. Listen to this delicious binding. And let's read about the Southern Hemisphere. Nice book sounds. All right. The Southern Hemisphere, September. This month, many of the constellations directly overhead in the evening sky have a watery connection. They include Capricornus the sea goat, Aquarius the water carrier, Pisces the fishes, and Pisces australis the southern fish. Let's see if we can find them. It says directly overhead, so I see Capricornus, Aquarius, Pisces. It's supposed to be Pisces australis, right? And what else? And Pisces the fish, just regular Pisces. Anyway, farther south in the sky, you can look for the bright star Peacock in Pavo. This star is a good signpost to the faint constellation of Telescopium, found directly to its west. Let's see, where's Pavo? It says farther south. So let's find, there it is, Pavo and Peacock. let's read about Capricornus. This fish-tailed goat is the smallest of the zodiac constellations. In Greek myths, it was linked to the goat-like god Pan, who gained a fishtail by jumping into the Nile River to escape a monster. Capricornus is directly overhead in September, but its stars are faint. To find it, look for bright Altair and Aquila and its two neighbors. They point southeast to Capricornus. And here's Pavo. This must be peacock. I wonder if it's named that because it's this brilliant blue color. I don't know. Let's see what it says. Pavo. This constellation represents the peacock, a bird native to South Asia, and that also features in the Greek mythological tale. Its brightest star is also named Peacock. The star Kappa in Pavo is a regular variable of the kind astronomers called Cepheids. Its brightness varies by nearly a magnitude over a period of 9.1 days as the star pulses in and out. So the whole constellation's a peacock. I wonder if this is the bird and this is the tail, I think. Interesting. Down here we have Telescopium. Boop, boop. This 18th century constellation honors the telescope. Close to its main star, Alpha, lies Delta, a double star, which with good eyesight or binoculars can be seen as two distinct stars. All right, let's carefully turn the book. It's a little heavy now. There we go. This book makes the best sounds. All right, let's see what we'll learn about this month. We are going to learn about Cygnus the Swan. Let me show you this page first. So here you can see what Cygnus looks like as a constellation. You can see its outline, its major stars, some of the points we'll talk about. And then we flip this over. And that's what Cygnus would really look like in the sky. Isn't that gorgeous? You can see the arrow right there that we just talked about. Was it Sagitta? Like Sagittarius. So you can really tell Cygnus because it almost also has a cross shape like some other constellations we've talked about, because it's a big swan and these are its big wings. Let's take a look at this. See what I mean? Big swan wings. Cygnus the swan. And Vulpiculus down there. We just talked about that. Over here we can see Delphinus. Another very distinct looking constellation there. Alright, let's read about Cygnus the Swan. The constellation of Cygnus depicts a swan. This celestial bird flies down the Milky Way, its wings outstretched and its long neck pointing south. In a Greek myth, the swan appears as the god Zeus in disguise. He took the shape to charm Queen Leda of Sparta, and as a result she produced eggs that hatched out into Castor, Pollux, and Helen of Troy. Cygnus is an easy constellation to spot because of its cross shape. It is also often referred to as the Northern Cross. Its brightest star is Deneb, 3,230 light years away, which may be as much as 250,000 times brighter than the sun. So you can really see Deneb right there. It's a very bright star. Let's read about the Cygnus Rift. Let's see. Splitting the Milky Way in two. It says the Milky Way divides Cygnus with a clearly visible gap between the two parts. This is known as the Cygnus Rift or Great Rift. And you can trace it right along the Milky Way to the constellation of Sagittarius. It is caused by dark gas and dust clouds along the line of the Milky Way that hide the more distant regions from view. The clouds are about 2,000 light years away from the sun. I've I've only ever seen the Milky Way once, and it was kind of faint where I was. I live in a place where it's not visible whatsoever, so I really want to be able to see it like clearly like this someday. I know I will at some point. Let's read about William Herschel. English astronomer Herschel began life as a musician. In his spare time, he made telescopes, and while examining stars from his backyard, he discovered Uranus. Herschel went on to build what was then the world's largest telescope. He also compiled lists of deep sky objects that are the basis of the New General Catalog, or NGC, still in use today. This is the North America Nebula, and you can tell it's very aptly named. Look, here's the West Coast, there's Mexico, the Gulf of Mexico, Florida, New England, there's Maine, the Great Lakes. Isn't that interesting? Getting the Rocky Mountains. What are the odds that it's shaped like that? It's so distinct. It's so cool. It's just missing Baja California. Anyway, the North America Nebula. Not far from Deneb lies the faint but famous nebula. Its name derives from the shape of its glowing gas cloud, which resembles the outline of the North American continent. It is not easy to see with the naked eye except in very clear and dark skies. However, photographs show it clearly because film is much more sensitive than the eye to the red light in that the hydrogen gas emits. And look, you can kind of see it in this picture. Actually, you can really see it right here. Let me flip this. And let me go like this. Look, can you see it? Right here next to Deneb. That's so neat. And there looks like there's one more nebula. A lot harder to see, the Veil Nebula. Look how gorgeous it looks. Wow. Some 40,000 years ago, a supergiant star exploded as a supernova in Cygnus. Our distant ancestors may have seen a brilliant temporary star in the sky, but today we can only see the remnant of the explosion in the beautiful wreaths of gas that form the Veil Nebula. The brightest parts are just visible with binoculars. The actual star that created the veil is now invisible. It is probably a faint white dwarf or neutron star that is impossible to detect among the thousands of other stars in this region. Alright, let's flip that over and learn a little bit more about space. We're going to talk about the inner planets. The 4 planets closest to the Sun are Mercury, Venus, Earth, and Mars. This group is known as the inner planets. Although they all have rocky surfaces, Earth is the only one where humans can survive. This is because our planet orbits the Sun in a region called the habitable zone, or the Goldilocks zone, I think it's called. Here, conditions are suitable for life because water can exist in liquid form without freezing or boiling. Earth is the only planet in this zone. Conditions on the other inner planets are either too hot or too cold. Let's start with Mercury. Let's go in order. Little Mercury. As the closest planet to the Sun, Mercury's cratered surface reaches temperatures up to 680 degrees Fahrenheit or 360 degrees Celsius. Mercury moves rapidly along its orbit at about 105,000 miles per hour or 168,980 kilometers per hour, a speed that takes it around the Sun in 88 days. This tiny planet is just 2,664 miles or 4,288 kilometers in diameter and is only visible at twilight every 2 or 3 months. Then we have Venus, big, beautiful, glowing Venus. see Venus in the night sky because it's so bright, especially at this time of year. It's usually the first object you see in the night sky if the moon's not up. It's so bright and vivid this time of year. It's one of my favorite things about autumn is being able to see Venus so brightly. Anyway, let's learn about it. It says Venus is the brightest object in the sky after the sun and moon. Its brilliance is due to sunlight illuminating its thick clouds, which consist of tiny droplets of dilute sulfuric acid. The clouds always hide the surface below, which is as hot as a furnace because the carbon dioxide atmosphere traps the sun's heat like a greenhouse. I'd say it's a lot hotter than a furnace, but let's read about it. The surface of Venus. Radar images of the surface of Venus reveal volcanoes and lava flows. The atmospheric pressure on the surface is 90 times greater than Earth's, and the scorching temperature reaches 860 degrees Fahrenheit, or 460 degrees Celsius. These conditions are so hostile that spacecraft that have reached the surface of Venus have only been able to return data for a few hours at most. Then we have the best planet, Earth. The very best planet. Look at the big swirly clouds. Let's see what it says about Earth's atmosphere. Life on Earth makes our planet unique. Water in liquid form is in vast quantities here, and this allows life to flourish. Water from the oceans evaporates into the atmosphere and forms clouds. It then falls back to Earth in the form of rain or snow. Earth's atmosphere is made up of nitrogen and oxygen with a small amount of carbon dioxide. Humans and other animals need oxygen to live, obviously. And here's the moon. Let's see, we talked about the moon last month, but let's see what it says here. It says, shortly after Earth formed, it was hit by a massive object about the size of Mars. This resulted in large amounts of rock being blasted into orbit, where some of it clumped together to form the moon. Over billions of years, impacts on the moon's surface have created huge seas of solidified lava, which we see as the dark areas of the moon. And down here we have Mars, big, beautiful red Mars, the red planet. Let's see. Today, Mars is a cold planet where liquid water cannot exist. There are signs that Mars was warmer in the distant past, with water flowing through huge valleys. The rocks on the surface are colored orange due to iron oxide, which is why this planet appears reddish in the sky. Frosty polar caps and dark surface markings are visible with a small telescope when Mars is close to Earth. And the surface of Mars. Don't you love all the pictures that Mars rovers bring back and how much it looks like Earth in a way? Let's see what it says. At first glance, Mars resembles a rocky desert on Earth. Sand blows around in the light breeze and forms dunes, but Mars's thin atmosphere of carbon dioxide has a pressure only 1% of Earth's, and even on a summer's day, the temperature barely rises to freezing. Yes, Mars is very cold because it's so far from the Earth. Look at the ice caps. So it's one of those places where, like, if we go someday, we have to kind of deal with the fact that it's freezing cold there. So, and also they have very, very violent storms too. So there's a reason that there's no life forms living on it. It's not very habitable, but I mean, NASA seems very determined to get men to visit Mars in the near future, so we'll see how it goes. I'm all for it. I'm not against it. I think it's cool, but anyway, I won't ramble about it. I'll let you go for the night. you so much for watching. I hope you found this video relaxing and educational. And I hope that you have a very good